All right, for the Learning Target 9 video, I've skipped the first probably 10 minutes of the lesson because in our bell work here, we divided two problems using long division and synthetic. Those videos are posted, so it's better to look at those videos than it is to go through that again. But now we're using those answers for this problem, 2x cubed plus x squared plus 1 equals 0. In Learning Target 9, the only change now is the directions just say solve. They don't say how, they just say solve. So what you're going to end up doing, if you haven't already figured it out, is cross your fingers, graph it, and hope to find all the answers right there. Okay? Well, when you graph 2x cubed plus x squared plus 1, we've already figured out if it's a degree 3, we're looking for 3 answers. We already know that. That's actually called the fundamental theorem of algebra. We'll associate that today. But when you graph this, you see this picture. Clearly, it's crossing at x equals -1, right? Crossing at x equals -1. And you see that twisting? Is that function ever going to twist back and touch the x-axis again? Then only one of the answers is real. The other two have to be imaginary. So we'll fill in our template notes here. If we know that there are 3 answers, the calculator says x equals -1 is one of those. We have an old box. I'll go ahead and scroll to the next page here. This is an old key concept that if b is an x-intercept, x minus b is a factor. If -1 is an x-intercept, like it is here, x minus -1 is a factor, or x plus 1 is a factor. That's an old concept, but I copied it again for the notes here. So x plus 1 is a factor. Now what that means is you can take this and divide it by x plus 1 and get some answer, question mark, which is what you just did in number 18. You just did that division right here. And when we divided, we got the answer 2x squared minus x plus 1, which means you can take this problem and break it into x plus 1 times 2x squared minus x plus 1. You are factoring it through division. And then you can solve those two like it's shown here. The x plus 1 using the zero product property, either it equals 0 and x is -1, or the quadratic, which won't factor. Try as you may, it just won't factor. Use the quadratic formula and you get those two imaginary answers for a total of 1. And then this has 2 answers because it's got the plus or minus, right? Okay. All right, we're skipping Learning Target 8 this year. So we're skipping the rational root theorem. We're skipping the Descartes' rule of sign. But we can't skip the conjugate root theorem. Okay, so for Learning Target 9, we do have to cover it. If you'll flip the notes over and read about the conjugate root theorem, I'll do the same on the video and pause it so you can read. We've already mentioned the fundamental theorem of algebra, but we'll talk about that again too in just a second. But I'll pause the video, read about the conjugate root theorem, and then I'll explain what you're reading. Go ahead and read the fundamental theorem of algebra as well. Okay, so that was, we paused. They read over these. Now let's explain what we read, because this is just math speak. It's math language. For number 1, the fundamental theorem of algebra, all that's saying is if you have a degree bigger than 1, so x squared, x to the third, whatever that degree is, that's how many solutions or how many roots there are. So for this example, x squared plus 2x plus 5 equals 0, there's 2 answers. And we figured that out, right? If it's a degree 3, there's 3 answers. Degree 4, there's 4 answers, etc. All right, now what about the conjugate root theorem? Well, the important part is here and here. That if you have a root a plus the square root of b, you've also got the root a minus the square root of b. They come in pairs, and you've noticed that. It's a square root answer. It's always got plus or minus in front of it. If one of the answers is 2 plus the square root of 3, then you can also assume that 2 minus the square root of 3 is an answer. That 2 minus the square root of 3 is an answer. All right, the problem that I put up here, this problem at the top, one of those 2 answers, one of them, I'm looking on the board, is -1 plus 2i. One of the answers is -1 plus 2i. You can assume that if -1 plus the 2i is an answer, then -1 minus 2i is also an answer. They always come in pairs. The quadratic formula, it's got that plus or minus in front of the square root. Okay. All right. Now let's put it all together. Example 1. Let's put it all together. It is given that I is one of the roots of this equation. Find the other roots. For your convenience, I've already graphed the function and put the picture down here. If you are interested, I can show you what buttons to push so that your calculator will split the screen too, where you can have the graph on one side and the table on the other. They'll all do that. But let's answer these questions that you should ask yourself every time. According to the fundamental theorem of algebra, how many roots are we looking for? In this problem, how many roots are there? Right. If it's a degree 5, we're looking for 5 roots. According to the conjugate root theorem, you may have glazed over that I. If I is one of the roots, what can you conclude based on the conjugate root theorem? Its conjugate, which would be negative I, is also a root. If I is a root, if I is one of the solutions, then negative I is also one. All right, so we've got 2 of the 5 so far, right? 2 of the 5. Now there's the picture of this function and the table. According to this key concept box, if B is an x-intercept, B is a root, right? So according to the table, 2, 1, and negative 2 are also roots of this equation. So negative 2, 1, and 2. So put it together, you found all 5. The 2, the negative 2, the 1, and then the I and the negative I. You've got all 5. All right, now the one I've got for you to try, example 2, has a little twist to it. So take your calculator and try example 2. Those at home, do the same thing. Take your calculator and type it in. There is a typo. Glad I caught it this time. That's plus at the end. Change that to plus 36. There's no subtraction in problem number 2. It's all addition. Change it. It's a typo. All right, so you learn more about learning target 9 the more problems you do. So while I'm only showing 2 in the video, and I'm only showing 2 in the notes, the more homework you do, the more you learn about learning target 9 and how division and factoring and roots and your calculator all play together. I mean, there's a lot more to learning target 9 than this video is going to discuss. All right, but I'll play catch up. Measure twice, cut once. When you're working these problems, make sure you typed it in the way you intended. All right, got it. So there's the picture on the surface. Now, there's a chance we're zoomed in and we aren't seeing the rest of this W somewhere. There's a chance, okay? So we may need to change our window, but we'll start with the questions that are on the notes here. According to the fundamental theorem of algebra, we're looking for how many roots? Looking for 4. And using the conjugate root theorem, if negative 3i is one of them, what's one of the others? Positive 3i. So far, if we're making a list of the 4 answers, it's negative 3i and 3i, and we need 2 more. All right, so here's the picture again. Think about it. That looks like it's crossing at x equals negative 2, right? Or touching. And if you go to the table, it does say negative 2 comma 0. So the question becomes, of the 2 missing answers, is negative 2 one of them and we're looking for another? Or is there something special about this one? There's something special about this. It touches and turns. Do you remember what that means? It touches and turns. It doesn't go through the x-axis. It touches and turns. It's a double root. You remember that from before the break? It's a double root, which means that negative 2 counts twice. Negative 2 is a double root. So you could write negative 2, or you could write negative 2, draw an arrow and say it's a double root, but it counts twice. You're not looking for any other answers. Your other 2 answers are both negative 2. All right? Again, disclaimer, again, so much more comes up. So much more comes up when you do the homework in the worksheet I've got here. So much more comes up about division, factoring, and whatnot. Okay? But that's all of the high points for the video.